The rule Marvel established. In Ant-Man, Hank Pym explains how Pym particles work. They don't change mass, they change the distance between atoms. That detail sounds harmless. It isn't. If mass stays consistent while volume changes, density must change. Density equals mass divided by volume. If volume shrinks and mass remains the same, density increases. And when density increases enough, matter behaves in ways that are no longer survivable. The film gives Scott a mass of roughly 90 kilograms, about 200 pounds. That mass never leaves. That mass never disappoints. It compresses. What shrinking really means. When Scott shrinks to the size of an ant, he's not lighter, he's smaller. That distinction changes everything. If a 90-kilogram human compresses into something a few millimeters tall, that mass is concentrated into a microscopic area. Pressure equals force divided by area. Reduce area, pressure spikes. That means every time Scott lands on something, he should punch through it. Every time he stands on a person's shoulder, he should pierce it. Every time he lands on a gun, the gun should collapse. When he fights Yellow Jacket at miniature scale, their punches should behave like armor-piercing rounds. The film briefly acknowledges this when Scott crashes through the bathroom tiles. The tiles cracked under his weight. That moment is correct. And then the movie forgets, because consistency would turn every stealth mission into a massacre. The ant problem. Throughout the film, Scott rides ants. Ants are strong. They can lift many times their own weight, but let's apply the rule the movie established. An average ant weighs about 3 milligrams. Even if an ant could lift 50 times its weight, that's 150 milligrams. Scott weighs 90,000 grams. That's 90 million milligrams. No ant is carrying that. Every time Scott mounts an ant, it should flatten them instantly. Instead of a cavalry charge, it would be a trail of crushed insects. The film shows swarms supporting him. Physics says otherwise. The growing problem. Now, reverse the equation. When Pym particles increase in size, mass still doesn't change. The giant ant near the end of the movie should still weigh 3 milligrams. But now it has the volume of a dog. Density equals mass divided by volume. And if mass stays tiny and volume expands dramatically, density plummets. Lower than air. That giant ant should float. Thomas the Tank Engine, enlarged to house-crushing scale, should not slam into a building. It should drift away like a parade balloon. Every large object created with Pym particles would become a low-density shell, impressive in size, weightless in reality. A true escalation. So far, the problem is inconsistency, but it becomes catastrophic at the end of the film. Scott disables the suit regulator. He shrinks beyond atoms, beyond molecules, beyond quarks, into the quantum realm. And here's where the rule about mass remaining constant becomes fatal, because density isn't infinite. It's a threshold. It has a threshold, and that threshold is a black hole. The Schwarzschild radius. Any mass can become a black hole if compressed into a small enough radius. That radius is called the Schwarzschild radius. For a 90-kilogram object, the Schwarzschild radius is roughly 1.3 times 10 to the power of negative 22 millimeters. Imaginably small. But the film shows Scott shrinking beyond atomic scale. Atoms are about 10 to the power of negative 10 meters. Quarks are about 10 to the power of negative 19 meters. Scott shrinks further, far further. If his mass remains 90 kilograms, he eventually crosses that threshold. And when he does, he becomes a black hole. But it would evaporate. Black holes can evaporate through Hawking radiation, but evaporation depends on mass. Tiny black holes vanish quickly, larger ones persist. A stable black hole requires only a few grams of mass. Scott has 90,000 grams. That's more than enough to survive initial radiation loss, meaning once formed, it wouldn't disappear. It would begin consuming matter. First the laboratory, then the building, then the city, then the planet. In trying to save his daughter, Scott Lang would have ended Earth. The atomic limitation. There's another flaw in Marvel's explanation. The movie says Pym particles reduce space between atoms. They don't shrink the atoms themselves. That means Scott should never shrink below atomic scale, because atoms still occupy physical space. Compressing empty space has a limit. That limit is when atoms touch. Beyond that, there's nowhere to compress. Yet the film shows Scott shrinking past quarks, past known matter, into a realm smaller than particles. That contradicts the rule. Either mass doesn't stay constant, or atoms shrink, or mass transfers somewhere else. The comic book solves this problem by stating that Pym particles shift mass into another dimension, meaning when Scott shrinks, his mass leaves our universe. That would prevent black hole formation, but the MCU never clarifies that. It insists mass remains. and that instance creates the singularity. Why this matters? Ant-Man isn't presented as a cosmic threat. He's comedic, grounded, human. But scientifically, manipulating atomic spacing is more dangerous than lightning or gamma radiation. Thor channels energy. Hulk converts gamma into strength. Scott alters matter itself. The space between atoms defines reality. Change it recklessly, and the universe pushes back. The cascade effect. Even before black hole formation, Ant-Man's density would create disaster. Shrinking into machinery would destroy it. Landing on circuitry would puncture it. Stepping onto glass would shatter it. In the airport battle of Civil War, one ant-sized leap onto Iron Man's armor should have drilled through the suit. When he expands into Giant Man, if his mass stays consistent, he should be hollow, light, easily knocked over. Instead, he behaves as though mass scales with size, which contradicts the original explanation. Marvel chose the rule that made for cool dialogue, not safe physics. The true irony. Scott Lang's a father. His arc is about protecting his daughter. Every major decision he makes revolves around saving her future. Yet the moment he disables the regulator, if physics applies, he dooms that future. He becomes singular, unstoppable, irreversible. The smallest Avenger becomes the last thing Earth ever sees. Could the MCU fix this? Yes, with one sentence. Pym Particles transfer mass to a parallel dimension. That resolves density problems. That prevents black hole collapse. That allows shrinking without catastrophe. But the first film never says it. It says mass remains constant, and science follows the rules it's given. The final consequence. Ant-Man doesn't need cosmic stones. He doesn't need celestial power. He doesn't need gamma mutation. He only needs one disabled regulator. And the rule that mass stays the same, from that, gravity takes over. Density spikes, the Schwarzschild radius is crossed, and Earth disappears. Ant-Man was marketed as the smallest hero, but if the science holds, he's the most dangerous force in the MCU. Not because he intends harm, but because density doesn't negotiate. It doesn't care about heroism, it doesn't care about love, it only cares about mass and space. And when you compress one into nothing, everything collapses. Marvel built a universe of gods, aliens, and titans, and the true extinction event is a man the size of an atom. That's not a hyperbole, that's physics. Ant-Man doesn't just shrink, he approaches singularity, and if the regulator fails, there's no Avengers Assemble, there's no snap reversal, there's no second chance, there's only gravity, and gravity always wins. That's the hidden truth inside Marvel's smallest Avenger, and it is why, under the rules the film established, Ant-Man could kill us all.